Unfortunately, time is never on our side as a human. We're always bleeding away time. And my robot project is sitting gathering dust while piles and piles of parts just keep growing and growing. So here's the latest part. It's by DFRobot. And DFRobot makes some great stuff. Actually, I'm really quite pleased with DFRobot stuff. Now, this one is the PM2.5 air quality sensor. And you're like, what is an air quality sensor? Well, an air quality sensor senses, you know where I'm going with this, the quality of the air. And that could depend on what you're interested in, of course, but for us generally it means dust and particulates, because if the air is dusty and it's got loads of pollen or whatever it is in it, those particulates, you're going to get an itchy throat, or it's just not good for you, right? So that's why we want to put something on a robot to let us know if its environment is dusty, because of course the idea of my robot was that it's going to go around and just send back information. So this thing, first things first, looks absolutely gorgeous. I mean, look at that. It's clearly a plastic unit in there, which has been encapsulated with these lovely metal shells. And that's because, of course, it's quite a sensitive piece of kit. I'm almost tempted to prise it open to have a look inside, but we might bust it up. But what it does, to cut a long story short, it fires a laser beam through a channel of air that it's sucking in. So that's why it's got fan on it. So I think it's either blowing or sucking, whichever it is. It's passing it through or out of here to here, right? And that's going through a little window where it's got an opto sensor and a laser, frickin' laser beam. And that laser beam, of course, is shining through that air, and any particles that it hits, it kind of goes, and this sensor in there actually measures the. Now, I don't know if it is as simple as an optosensor, or it might actually be a CCD, because it could be looking for something more interesting. And you can see here its effective is 0 to 500 UGs per meter squared, so micrograms per meter cubed, sorry, not squared. And the maximum is 1,000 micrograms per meters cubed. I don't know, 1,000 sounds like a lot, like really dusty. I can see on the PCB here it says I²C, and it does look like, of course, this sensor module itself is mounted onto this board. So you could probably shrink things up a bit by connecting straight into that end there. However, you will notice, of course, there are a lot more wires coming off here than you have out here. So it's converting, this board is a converter, converting whatever this is using to I²C. And it does say gravity on it. I'm not sure what gravity means. Is it gravity? You have to be careful which way around you mount it. Anyway, that's something that one would have to read in the instructions. And I tend not to bother with those. So what I am going to do is want to see what this is up to. Now, I thought it would be nice to get out our old LED. I mean, this is kind of my go-to sometimes if I want to do anything with an Arduino, because it's just got loads of bits in it. So you just crack it open and we'll see what we'll need. So there's our Arduino. And unfortunately, and this always is the case, those things want to plug into pin headers, and we don't have them on there. So I'll probably just use a little bit of breadboard. There's some here, and I'm going to start to put it together. Now, something we don't have in this kit though is a screen. And I always think it'd be nice to have a screen in it. So I'm going to augment my kit here with one of these little OLED screens. And if you follow me in Discord, by the way, it does have a screen. It has an LCD screen, but that's got multiple pins. I'm talking about a bust screen, like an I²C or SPI screen. So I'm going to use one of these SPI screens, which you've seen recently on my Discord running on my Raspberry Pi Octoprint server, so I can read its IP address. And I'm going to wire that in and just leave that in the box. There are other sensors in this kit as well though. There is a humidity and temperature sensor. There's actually a joystick module which is cute, and if I recall there's a magnetic and accelerometer, so even the kit itself has additional sensors. But I'm going to start hooking this up. Just a bit of housekeeping to do before we can go any further. So I'm taking the connectors here and I'm just pushing through some old bits of component leg, and what I like to do is push them in like so, and just be careful, because depending on how you've cut it, like that, it sticks into your fingers, so you could be stabbing yourself in the fingers, just putting that in the edge connect again. Don't push it by the end because they are so sharp, especially depending on your side cutters. It might have just taken a good edge on it. And then just trim them down, and you can just obviously try one in your breadboard first to make sure it's the right length. Then you can just hold it like so. Let's try to show you some contrast there, and then just whip those off. Boom, you've made it breadboard compatible. Now for the OLED screen, it's something similar. You can see a little bit more involved. What I've done there, I've again poked through 4 legs into that breadboard, and I put the screen on because that's the way I want it. And I'm just going to touch them with a soldering iron. Just a touch of solder. I'm just going to turn it this way. And we should be reasonably clean, and just don't hang around too long with it, but get one done first, like that ground. I'm going to hold that with my finger and then just take any tension out so it sits nicely, and then I'll just continue with the other 4, well, other 3 rather. And then that itself also is breadboard compatible. Now I'm going to chop those wires off because they're obviously a bit excessive, but this is an I2C bus, so technically you could plug something else on the top of that if you really wanted to. I'm not going to. Just pop it out like that. As you can see, that's how it looks, and just trim them up. That'll do for now. And finally we're just hooking up similar pins to here, so you can see I've actually attached ground and 5 volts there, and then flipping it over you've got the SCL and SDA, apologies, for the I2C. And again, try not to use your fingers to push them home, just in case you might end up stabbing them. And let's just do that final hookup. So I'm just going to choose, well, let's see, my colours here aren't ideal either way, so I'm going to choose black and red for the power, black being the ground and 5 volts. That will do nicely. And then I'm going to use the blue and green for the other 2, and I'm going to make the blue the SCL, and you'll see why in a moment we want to do that. So there we go. Just push those on. For whatever reason that one's not quite going all the way in, but it doesn't matter. As long as it feels firm, it should be good. So blue on SCL, green on SDA, and flip it over this way and you can see black on ground and red on 5 volts. So we're going to go to the other end now, and that you can see how I've actually put the OLED on there, and I've got power buses coming through to this rail here just to give us a bit more room, but really we don't need to. We could just, in fact, let me just show you. I'm going to whip those out and put them aside. We don't need those because you've got here ground, VCC, SCL and SDA on our OLED screen, and we do know that the power from the Arduino we've hooked up as black for ground. We've hooked up red for VCC and we've got, I'm going to just tear these off so they've got a bit more play. We've got blue for SCL, and we've got the green for SDA. So actually, I know it looks relatively complicated, it isn't. Everything is actually hooked up there. So just as a sort of system diagram here, we're going to power up the Arduino, and that in turn then will send power to this junction here, because these 2 things are connected in parallel, so these will both power up at the same time, and then of course they're both connected to the I2C bus, so they'll both be active on the bus. And the difference between the 2 is they'll come with different addresses. This is normally a 3C, and we'll have to figure that out. But let's move across to the PC and we can actually start looking in the Arduino software. So the first thing you need to do, of course, is go on to arduino.cc and download the Arduino Ide, which I'm going to do here. So I'm going to install the Windows 7 and newer. Just download for now, thank you. Away it goes. And there's a survey and stuff you can do. If you're that way inclined, you've got plenty of time to do it. 40 seconds to download. Installing, yes, install everything. I want it all. The moment of truth, let's see if it's loaded. Arduino, excellento. Right, allow access. I guess so, we're going to allow you. So as you can see, you've not got much on the screen, and it does say Arduino Uno, and I guess that's close enough. I'm going to click Get Board Info, see if it can talk to it. Nope, it says please select a port to get board info. So I'm going to click COM11 now. Get board info. There is our board info. Now looking at the DFRobots website, and you have a nice website about this, so they can tell you about how it all works and what those values mean, the 2.5, because there's different particle sizes, stuff like that. And it also has a table here that shows you the different concentrations based on these WHO guidelines, and if it's excellent or poor or bad, and all that stuff's great. But the bit we're really interested in, wiring diagram, that would have been handy. The bit we're though really interested, of course, is how to install it, and it does say something about needing a library file, the DFRobot Air Quality Sensor. So what I'm going to do is I'm going to check here using the library management to see if that's something that's published online, or if it's something that we're going to have to install from a file. So I'm going to paste DFRobot Air Quality Sensor in there. Java.utils.concurrent modification exception. It's not looking good, Mr. Arduino. The Arduino Ide does have some issues. So I couldn't find a pre-built library in the library manager. That's absolutely fine. So what I did is I followed the link on DFRobot, which took us to the GitHub account. Now in the GitHub account you can go through and look at the source code. You can see there's an H and a CPP file, and if you want to see exactly what the sensor's doing. But what you really do is you just click download here, the code as a zip file, and then go into Arduino and basically extract it into the libraries folder. So that's what I've just done there. I've chucked it in the libraries folder, and I've actually saved this sketch as a sketch called Particle Sensor. And the next thing to do then is go on the DFRobot website, and you can see here they actually have a whole bunch of source code. So what you could do, it says sample code standard particle concentration. So I'm just going to cut and paste that. There we go. And there are other examples there, but I'm not going to look at those for now, because I just want to make sure everything's working. Because this is the first time we've installed the Arduino, first time we've set everything up. So then I'm going to click this little tick button here, it says verify. It's going to go run through, and yeah, as per usual, starts coming up with some errors. And let's see what it says. Now the error debugging isn't great, but you just read what you got here. And it says here, error DFRobotic Air Quality Sensor does not name a type. Did you mean DFRobot _ Air Quality Sensor, all one word? Maybe. Let me have a little figure out, see what's going on here. I thought I may have done something wrong by including the contents of that zip file directly into the libraries folder. So instead I went up here and I said include library and then add zip file, which then added this DFRobot Air Quality Sensor option here in the bottom, which is great. And of course, more errors. Still messing with the include string, and it's still messing me around. I finally got it to compile just using literally the example that they give you in their GitHub. So yeah, ignore the example that's on their website, go straight for the GitHub. Now let's see if we can actually see though. We've programmed the board, that's great. We want to run the serial monitor to see exactly though what we're seeing. Sensor begins success, and then we're seeing squiggly digglies, and I suspect that is the data, just not formatted in ASCII. Yeah, probably a better idea though to set the baud rate in your terminal to match your program. Enough of that though. Right, we're getting some numbers here. We need to figure out a way that we can actually start testing it though. In my hand I hold a box of matches. Of course it's running. You can see the numbers in the screen flashing up there. I'm going to clear the output so you can see they're moving. I'm going to light the match and then I'm going to let it blow out. So first I'm going to light it. Light, damn you. It's been so long. Oh. It lit and then disappeared, but you can see that was enough. That was enough. Literally, that was only a few nanoseconds that thing lit, and it basically disappeared. But it is definitely recording that, and you can see the PM2 concentration is 25 micrograms, PM1 22, and PM10 is 32. That's crazy, isn't it? That's how sensitive it is. I mean, there was a little bit more there, just a tiny little poof of smoke. I mean, we're talking not even a lit match, it's just literally a sparked match because they're old matches. But that's cool, and you can see that now. It's definitely reporting. I'm going to have a little blow on it. I want to see if I can affect the figure by just trying to clear the air, but look, it's not having it, is it? Clearly it's dispersed in the atmosphere. So the next stage now, I think, is to get the OLED screen working, so then we can actually take this to the bench and again have that another little play. This is the final stretch. It actually is working and sitting down there in front of me, buzzing away nicely. But I can tell you what I've done. You can see here I've added this Adafruit library. It just happens to be compatible with the SSD 1306 based OLED that we have here, and you can buy these anywhere. I just get them in these baggies. And you can see here I've defined the screen width and height to be 128 by 32, which it is. The screen address is at 3C hex. And OLED reset, I'm not sure we use this, but you just pass it through it. It's one of the parameters that the Adafruit thing works, and it's fine. We're not using those pins for anything else, so just give it to it as is. It's happy enough. And then what we've done to get this working, you can see after the actual sensor setup code that's here that was provided by the other driver, we've added, sorry, that's here, we've added here a call to the Adafruit library. Could make that a little bit clearer for you here, which basically says configure the display, and it just calls things to set up the display. That's why you can see here if it failed, it says the allocations failed. It basically mirrors the buffer of the display. So if you can imagine the oh my gosh, 128 by 32 size display, you've got memory area now inside your Arduino that's mirroring that, and that's what it's doing. And now it's just here, goes on, says clear the display, and then display.display means now flip that buffer, flip that memory down the I2C onto the actual physical device itself. So you see that a lot. And you'll see that here again here. So where it says clear display, it's running through now the loop. It's clearing the display buffer every time it's got a result. And it's setting the text size to 1, that's the smallest font, and it's setting the color to white, that's what we need. And then literally it's moving the cursor, and it's giving it XY coordinates for that cursor around that bit of memory. And then we're formulating this string. So we're writing PM1 onto the screen, and then we're taking the value for PM1 for the actual sensor itself, and we're converting it to a string, and then we're concatenating it with the micrograms per meter cubed bit of string on there. And then you can see we're moving the cursor to the next positions. Then right at the end we're saying display. So it's basically flipping now that bit of memory where it's drawn all of this internally and then pushing it out to the actual physical screen, and then we see it on the OLED, which I'm going to show you momentarily. And then that just goes round and round forever. So now on this device you can see you're going to get OLED display of the concentrations, but you're also going to get the same message out in the serial port as well, which of course you could use if you were integrating it with something else. And we're back to the mess on the bench. So what I'm going to do is take our Arduino and I'm going to plug it into a USB power supply. So we do have power, and that's sitting over there in the corner. We don't need to worry about that so much. And we're going to take our sensor and range it somewhere nicely, because we're going to play with that right now. And hopefully you can see the screen. In fact, let's put this here so we've got a bit of room. And we can just zoom in. We can just zoom into the parts we're interested in. So you have the sensor right there on the right, and you have the current display going on. And what I do have is my box of matches. So I'm going to try to attempt now to light a match. And you can see that here in the corner. I'm going to do it quite near the unit. Let's push this up here so any smoke gets sucked in. And just as a sanity check, you can see it's currently reading 0, 1 and 1. Yeah, you got that right there. 0, 1 and 1. Let's do this. You can see why I was having so much trouble. Right, so we had a bunch of smoke come off there. Whoa, and right away, you can actually see those going up immediately. It does appear that potentially, did I type that in wrong? That should say PM110 rather than PM210, but don't worry about that. That's what we're interested right now. Now the match is getting very low to the end, so it's going to pop a lot of smoke, and there it is, a big old waft, a big old load of it, and you can see that's jumped out a huge amount now. So if we had this now hooked up to an external fan, we could say when the concentration of these gets too high, then to turn the fan on, because we want to blow all this away, we want to whisk all that away. So just routing through the box, here's an example. So you've got a fan here. So this could be your like Dyson air cleaner. And of course, you can't drive this directly from the Arduino. You will have to go through a transistor or any other kind of motor driver. I'd suggest a simple transistor. And that's exactly how those air cleaners work, those fans that you buy, the very fancy ones. What they do is they're sampling all the time. Then when they see this go up, and you know, because of whatever environmental issue, such as maybe someone has just blown out a match, or perhaps it's just hay fevery stuff, pollen in the air, dust, those sorts of things, and you've seen them, the fans come on or the fans ramp up to pass air through that filtration system. That's exactly how they're doing it. And then when that number goes down to an acceptable level, they just turn it off again. So that is kind of interesting. That's pretty cool, and it's nice to have something that's kind of working for a change. So thank you very much to the people at DFRobotic for making such a handy little gadget. This is definitely going to be an easy to use module for any future project, really. Just anything with a nice squared C bus, and you could see how easy that was to chuck on. Anyway, thanks for watching.